The environmental costs of mountaintop mining valley fill operations for aquatic ecosystems of the Central Appalachians. What is mountaintop removal and MTVF? Coal provides around half of the U.S. with electricity each year. It is made of minerals that are formed from the creation of rock made in wetlands. The minerals in coal are full of organic carbon that produces energy when burned. The coal mining process begins with the removal of forests and topsoil of the mountainous region. Explosives and heavy machines are used to clear the rock and dirt covering the coal. Draglines then remove excess debris to expose the coal seams. This process results in a large amount of rock and coal waste that is then pushed into the valleys nearby, creating valley fills that bury the headwater streams. After the coal has been mined, companies are required to add a topsoil substitute and seed the area. How are these processes regulated, and by whom? The U.S. Environmental Protection Agency, EPA, the Army Corps of Engineers, ACOE, and the state government environmental and natural resources departments create acts to regulate the process of coal mining. An act known as the Surface Mining Control and Reclamation Act of 1977 requires all surface mines to be regulated and inspected, and all abandoned mines to be restored or reclaimed. The Clean Water Act of 1972 was created to maintain the rivers, streams, and bodies of water by requiring that the discarding of waste, such as rocks and excess coal, be avoided, and if unavoidable, restoration of the streams must occur.
Local environmental impacts of mountaintop removal include stream and soil losses. During mountaintop removal, a portion of the draining stream is converted into a sediment pond. This then leads to a net loss of habitats and ecosystems in those streams. The removal of vegetation also changes the materials in those streams. An example that is shown in the article was the fish that are living in those streams, especially the headwater species, are not found anywhere else in the river network, but then are also losing their ecosystem through the coal mining. Another impact is the soil. The loss of soil is one of the more long-lasting and permanent losses from the coal mining. While coal mining occurs, soil carbon and micro and macro nutrients are lost. The impact of vegetation also is not able to grow in thin soil and can hinder the growth. Both in vegetation and soil, there is less carbon in the coal mines compared to the forests and grasslands that have not been affected by coal. This photo of a stream is how coal mining has affected the streams surrounding the sites where the coal mining takes place. In this photo, you can see that the water levels are super low and that the water is super brown, which is neither good for the ecosystem living in or surrounding the stream.
Major impact from mountaintop removal is the effect that it has on the wildlife. Mainly the aquatic life in that area feels the most impact, as the streams that were closed up by the mountaintop removal were their home and their safe space from predators. They would stay there to keep safe, and they would lay their eggs there. When a mountaintop removal wipes out those streams, they either must relocate or they will not survive. When these species are eliminated, the biodiversity in the area goes down, which can disrupt many, many ecosystems. The map on this slide shows the impact that mountaintop removal can have on species in their areas. This map shows the fish and mussel species that are considered at risk, and if you notice the areas that those red and orange and yellow spots are in, those are areas where mountaintop removal mostly takes place.
MTVFs have far-reaching downstream impacts due to the export of sediments and dissolved substance from mine watersheds. Furthermore, the removal of vegetation and flattening of valley contours pose major challenges for restoring the landscape on mine sites. For example, as toxins wash downstream from mining, they kill wildlife outright and poison animals that survive in that toxic environment, which in turn spread these toxins to other creatures. As a result of the cumulative effects on altered flows and pollutants from current and past mining, the environmental impacts of MTVFs are severe, large, and long-lasting. They can be harmful to living species as well as the environment. In addition, several ions present in mining-derived runoff can be lethal or toxic to aquatic life on an individual basis. However, the cumulative effect of elevated concentrations of multiple contamination can result in substantial reduction in aquatic life.
What could be done to improve the current deficiencies in reclamation and mitigation? A way to improve these current deficiencies is to generate waterways on the mine site, as well as to repair and improve damaged streams in neighboring basins or waterheads. Another way is to do more restorations of new streams and channels of water rather than building them new, due to the fact that when restoring these streams and channels, it will still have intact its natural flow of water paths. This is also favored more than reconstruction as well. Another way to improve these are to have ephemeral and intermittent streams, also because it provides a unique habitat for diverse populations of insects and other animals.